Yeah, so Oliver Wilton, I'm going to speak about work from the Bartlett School of Architecture, involving obviously a lot of students and colleagues. So yeah, we can go to the first slide. Okay, thanks. Yeah. So I thought, it was nice to be asked to talk about this topic because I'm pretty interested in it, and I think it's quite a broad topic. So experiential pedagogy is something I think we're fairly great at in architecture schools, and for me, this is a part of it too. This kind of event, the discussions, and within that is learning through doing, and then learning through making is a sort of subset of that, which is what I'm going to be focusing on today. So. Yeah, and so I think at the Bartlett it's used. I'm just going to give some general introductory points, and then we'll move on to look at some examples. And so at the Bartlett we use learning through making. So there's a kind of learning some of the basics is done through making methods. Yeah, sort of introductory fundamentals, and students then go on. Some students then go on to use making and design research methods that are used more as we go up through the school, and that's something that staff we sort of encourage and help to enable that, and we also do a lot of it ourselves, and so there's it's a part of the culture of the school. I'll show you some examples in a minute. So just a very brief history. So the Bartlett's a pretty old school. Architecture's been at UCL for about 180 years, yeah. But there's been a lot of change in recent years. So about 20 years ago, it was about half the size it is now. And we had the standard sort of professional programs, BSc and Diploma Architecture, and 2 or 3 master's programs. And in terms of the sort of facilities and expertise that we had around making, there's desk-based making, so almost like getting a piece of cardboard, traditional architectural model making that architects do as a part of their design development. There's been strong support for craft space making in the school for decades, particularly around woodwork and metalwork. And there also used to be machine tools for people who like that, so you'd be able to sort of get a lump of steel on the lathe and sort of time-consumingly mill it if you wanted to, that sort of thing. And there's been a big shift over the last 20 years. We're now, as I said, the school's doubled in size. We're now across 4 campuses, so it's a very sort of diverse school and quite divergent in some ways. So it's hard to give a kind of summary of what we do really. But I'm going to be focusing on the professional courses in terms of what I'm talking about. So during this growing process, we had a chance, rather than just grow our existing courses to a sort of huge size, we took the decision that we wanted to introduce some new courses. And so that was quite nice actually to just reflect back on what the strengths and priorities were for the school, and to produce some courses that were tailored in relation to those interests. So we introduced some more professional courses, including landscape. We introduced an engineering and architectural design course, which is triple accredited, which is quite an unusual thing to do in the UK, where empirical methods are very much to the fore. We're using architecture design studio methods in an engineering course, which again is unusual, and making is a part of that. We also introduced a number of specialist masters, which are very specifically around experiential pedagogy. So there's design for manufacture, so that's very making focused, with students having a particular interest in manufactured construction systems basically. And they also have a lot of fun in our robotics lab, playing around with experimental forms of construction. There's design for performance and interaction, which is more centered around the body, performing arts basically. Yeah? And there's also a sort of interactive architecture and video aspect to that as well. And the facilities and expertise that we have in the school have grown a lot around making in the physical recent years. And that's partly thanks to Bob Shield, who was the head of school for around 10 years, who really sort of promoted that and promoted those sorts of methods of working. So we still have the sort of, we still have desk space and craft space making. Working with earth-based materials and ceramics has really become of interest to a lot of people in the school, and we have some ceramicists now who support that work. And I'm sure, as here, you know, there's been this sort of explosion of digital tools, which gives students a chance to do things that would have been pretty much impossible when I was a student, given my very low level of skill. So suddenly you're kind of opening up these new vistas in terms of what you can do, what you can actually create as a student, and that has these interesting and complicated correlations to architecture practice and to how the construction industry could evolve, you know, when you guys are leading it over the next couple of decades. So, yeah, CNC machinery, robotics, 3D printing. Also at the Bartlett, there's been a strong interest in 3D scanning, so LIDAR, photogrammetry, and we've had a company that's started up in relation to that. And there's also a little bit of lab work, because we have a biointegrated design masters now led by Marcus Cruz and Brenda Parker, which is sort of making, and they try to grow hairy stuff on buildings and things like that too. And so they've got labs where they're not supposed to grow anything dangerous, because it's quite a basic lab, but they grow things, and so, you know. So that's quite a rich mode of practice that involves kind of fairly experimental making methods on different substrates, and then they're trying to grow things. And so hence that's why it's a post-professional master's, because you can understand that quite quickly that becomes quite involved. And it's actually unusually one of our only 2-year master's programs too, because you're bringing together different disciplines there, so that's what's supposed to do. Okay, next slide please. Thanks. Learning through making. Okay, if you can carry on through. Okay, so yeah, so why bother to make as a part of you know, how you learn? Well, for me, I mean, one of the things is it is a lot of fun. You know, in my experience, students do get a great deal out of it. I think it's fun because well, it gets you off of the screen, which is great in my view. And also there's a kind of amazing learning curve where obviously we've kind of evolved to be like this over millions of years, and when you're making, there's this kind of haptic learning curve, which is difficult to get just by looking at a screen. And I think also students can get a sense of satisfaction of having actually achieved something or created something, yeah, which you can then go back and reflect on. So I found, this is some stuff I was doing sort of 25 years ago. I think that's true if it's individual sort of play or or when it's group work. So this is something that Klaus mentioned. That's something that we organised last summer, and we had to import some French people to deliver it, and they're amazing. 2 guys called Paul, Nougarit and Vergonjeune, something like that. Yeah. So they were fantastic, and so this wasn't a part of the core curriculum. This was a week-long summer school that we ran, and it attracted. There were a lot of our students and staff, and it attracted people externally too. So we had people from first-year architects through to company directors, and there were architects and engineers, and we had a few stonemasons in the mix too. And the learning curve was great, and I think everybody really enjoyed it. So it'd be amazing to do more of these things. It takes quite a lot of facilitation and infrastructure to actually sort of organise these sorts of events, but I think they're fantastic when they happen, and it sounds like you guys are very lucky that you're involved in something like that here at the moment too. And I think the main barrier to this sort of thing in UK anyway is just funds, and actually the pure logistics means that there's a high barrier to doing it, but whenever it happens, it seems to be fantastic. So could you play the video on the right, please? Yeah. So, you know, so this is this kind of group making project again, yeah? So students made this kind of weird looking structure out of bath stone. And I think, you know, one of the great things about these projects is there's a sense of a time frame and an objective, and that leads you through these learning processes. And you can see in the end making this kind of weird looking arch that didn't collapse. If you could play the left as well, please. But you know, and I think the valuable learning happens en route. Really, it's not happening in relation to that final moment particularly. For example, this is great where these students have made their first sort of masterpiece in stone, and then the instructor decides he wants to test it, and so he just he hops up. happens. Okay, yeah, and he breaks it, yeah? And so there's some good learning to be had there, like why did he do it? And, it builds resilience. But obviously, I think, the thing about these sorts of projects is that effectively what you're learning is a large part of what architecture is all about, yeah? which ranges from obviously the team working is an aspect, but you see that whole trajectory from concept through parts, assemblies, structure, through to some form of habitation. There's an aspect where there's a site-specific character, where you design for a site and then you reflect back. There's some, obviously architects are often involved in a lot of production of design information broadly, and you can see that trajectory of how this shifts from a first sketch, conception, through to design development, through to design for parts and assemblies, and so it just feels like you could do an architecture degree purely based on these methods if it would be possible to facilitate it, and you'd probably create amazing architecture. So if you do it in a week, it feels worthwhile. Thanks. Getting started. Okay, so I guess in the Bartlett, just to put it in very straightforward terms, what we tend to do is that in the first year, early on, get quite a lot of prescribed, quite small modules where students are learning basic things, and there's a kind of core curriculum, and there's a lot of introductory things happening. Yeah? And then as the years progress, the aim on our courses in general is to have larger modules, less of them, with more open learning outcomes, so that as the students figure out kind of what they're interested in, what they want to pursue, then they get increasing agency to sort of pursue and become people making decisions and setting directions, and to a certain extent gaining a kind of expertise in the form of practice that they want to pursue afterwards. Yeah? So these first year examples are the kind of introductory thing. So this is, Klaus, you teach on this.
That's me over there.
Who is it? Oh, yeah, no. Look, this class in disguise, the photograph. Okay, so this is our engineering course. So these guys are doing a lot. They're becoming architects. They're learning how to do the sums that an engineer does too. And this module, Design, Make, Live, is aiming to help them, as a microcosm, to see the relative role of each part and to see how it works in the overall process. Yeah. So it's called Design, Make, Live because the idea was obviously that design, make something, and then potentially live in it. But it's quite difficult to live in things like that in a park in London. So I think there's a sort of inhabitational aspect where there's some form of inhabitation and there's a kind of exhibitional character and a presentation. Yeah. So anyway, we can go on to the next slide. So yeah, so you can see here students putting proudly putting the finishing touches to some of their pavilions on this small module. And as I say, by the time they've got to that, they've gone through really what's quite a sophisticated methodology working together. Another important role of our first year is that our students come in and they're a mix, maybe half UK, half international. But say in the UK, students typically do 3 A-levels at school, and quite often our students will be doing, say, maths, physics, that sort of thing. So they're incredibly narrow and prescribed, and very useful in relation to certain aspects of architecture practice. But they don't. But there's a right and a wrong answer. It's not a kind of more open humanities-based practice. And so part of, for A-level too, after lockdown and things too, it's become perhaps more so that you can actually have quite a monastic form of practice and to get some good A-level results where you don't leave your bedroom for 2 years and then you get the right answer in physics exam. And that's all great, it serves a purpose, but the architecture school environment's very collaborative, and there aren't that many group projects, but in general there's a kind of collaboration and a peer learning and a discourse or discussion that goes across the work, and that's a really important part of the pedagogy. And it takes a little while for quite a lot of the students to sort of transition out of the monastic scholar mode and into these more active forms of practice. Yeah? So they're learning how to make things, but they're also learning how to engage socially with the team and the broader cohort, and that's a really important part of it. And they're important skills to have, but it can also give students a lot of confidence to actually move forward. Okay, yeah. So this is just one of the towers which was deployable, and people seem to love it, and it carried on popping up afterwards at various things unexpectedly. So our BSc architecture course is it doesn't have the in-depth engineering component, and there's a stronger linkage to culture and arts practice, I'll say there. So this is some of the sort of making stuff that they do in the first year. The World of Fragile Parts, they did this a couple of years ago, and they teamed up with Brendan Cormier, who's a curator at the Victoria and Albert Museum, and they visited the cast port there, which has full-size cast of historic architecture parts and fragments dating back millennia. And so this was also then linked into a discussion around authenticity, the original, the copy, that sort of thing. So there were sort of other things mixed in with this. So this first exercise was done as an individual exercise, and you can see there's a kind of relationship to the body and the senses that links back through to sort of architecture and art history. Next. They do a second module too, which is a little bit similar to the engineering one, but I think there's less of a focus perhaps on fundamental considerations around architecture, structure, construction, and again there's a more of a performative or sort of theatrical element to it. Yeah? But again, you can see that students will be learning, working together, making parts, carrying them down the street to St Pancras New Church, where they put on, where they create installations, and then they're sort of presenting these to critics. They're presenting and performing, and there's that kind of discourse that happens in relation to the work, which is, that's for me that's a pretty nice, well-evolved form of pedagogy where you can learn a lot, and it's useful skills to move forward into architecture with some confidence, and there's also a lot of transferable skills that students are learning when they're doing this sort of thing. Okay. Yeah, so I'm just going to talk through, one of most of my involvement's actually in the later years where students do research dissertations basically, yeah? And they really, they can just research pretty much what they like, and they produce a research proposal which is a bit like a doctoral research proposal, where they write a page or two saying what they're interested in researching, the context, what methods they think that they want to use, and then we allocate to them specialised tutors. So it might be a historian or a cultural theorist or an architect like me or a structural engineer. And these are some examples of the sort of work we do. So here you can't read, but Georgian Panay this year was looking at stone in Portugal, historic practices, and he visited quarries and he saw that the industry supplying global markets for very clean stone, and as a result, a lot of the stone never leaves the quarries because it's not of the right sort of visual character. So he sort of was interested to create a Portuguese architecture which was tailored around environmental sustainability considerations, and so he looked back at the historic practice of splitting stone, which is what he's doing here. Yeah? So he was reasonably handy working with stone to start off with, which is quite helpful because, like, compared to timber, it's pretty difficult to do anything with a bit of stone. So what he's doing here is he's trying to get double axis stone splitting. Yeah? So it's historically used just single axis just to split a big lump of stone. You can't really hear this, but he's listening because the stone is singing back to him when he's hitting it, and that the higher notes are indicating a higher stress level. So he's trying to balance them across the plug and feathers as he's hammering a bit of Molianus limestone, which is from Portugal, and so you sort of wonder if anything's going to happen, and you see it's quite patient. And let's see. Oh, there it goes. You see? So anyway, yeah. So just taking a historic method, which is a low carbon way of cutting stone, because you don't have to abrade a huge amount of it, and looking at how you can take that forward. So you can see in this case there's no CNC or any fancy digital stuff involved. If we go, yeah. So he worked through to start getting 3-axis splitting methods going, and then he took that through to, so this is really just an abstract kind of material techniques piece of research. And then he took it through to starting to create an architecture, a form of architecture based on this, yeah? So this is a window reveal piece that he made at full size, yeah? And what you can see he's doing some quite serious splitting there, and okay, we go to the next thing, yeah? And this is the final piece. So what he realised is, in some cases you really don't need any particular tolerance on a piece. It could go all over the place. It's just a wall, you're working with a large piece of stone. And then he developed methods to bring the tolerance down at the point where you need to fit a window and that sort of thing. Okay, so, and this is the kind of work in progress. Okay, so this is Finbar Charleston, who was interested in just working with engineered timber, really, yeah? and looking to this age of timber that we're in, we're right now, where timber's sort of stepping forward, engineers stepping forward, and having the kind of fun that steel and concrete had over the last number of decades, yeah. So Felix was interested in tailored, anisotropic character of timber, tailored veneer use, looking back to sort of famous examples of the Eames splint and that sort of thing. So this was a kind of playful start where he just started making a lot of little maquettes, using tailored veneer cutting and assembling these things just to sort of think, what kind of architectural language might we generate here? And he moved through to some more tailored pieces, so looking at a tubular engineered timber structure, how could we make a connection? So, there's some quite involved work here that relates to the character of the timber, but how you make the form work and how you get it out of the piece at the end to make pieces like this, playing around. And then he moved on. So a lot of these projects then look for an application to an architecture design project, which the students undertaking. So developing these timber trusses and discretizing them into parts, and then making a part. Yeah. So there's a lot of scaled making, constructional making. It's nice to make things one-to-one if you can inhabit them, but quite often when it's a learning exercise or a research exercise, it's kind of good to make the scale as small as you can to get the result that you want. Because otherwise you're just making a load of stuff that goes in the bin next week or something that's much bigger than it needs to be. So yeah, there's a lot of nice work around around scale making. Yeah. Okay, I'll give you a couple more examples. So something that's happened also is that students are contextualizing their work a lot more than they were 20 years ago. 20 years ago in the Bartlett, quite often it was more like arts practice. They wanted to make something new that was kind of outrageous, and often they didn't know what it was made of, or if you asked them it would just be concrete or something. And students are much more socially and environmentally aware now, and so they're always thinking about context and what the role of architecture is in relation to them. And so quite a lot of the choices on materials and forms of construction are directly informed by that. Yeah. So the making is a part of this broader methodology, which I think students are using quite sophisticated methodologies now, with making being well tailored to sort of slot in as a part of that. So Felix Segar was looking at chalk cob, which is a historic form of construction in the UK, at a cement works site. So there are a lot of these on the south coast where I live, in the chalk downland, where they started off making lime. Farmers would dig out chalk to make lime sort of 100 years ago, and then they transferred into cement works. So this is a chalk quarry and cement works. And then over recent decades, they've all closed down. So they're just these huge derelict sites, and there's this kind of scarred extractive landscape. So Felix was interested to consider, what the future for this place could be, and he was interested in kind of, rehabilitating it. And so, and obviously there's been a lot of extraction there. So between us, we identified there's a Crossrail project in London that recently constructed an underground railway crossing London. So he identified a site where you could get chalk from them because they were digging it out of the ground in huge volumes. Yeah. And the plan was to use this chalk filter cake, which is like chalk toothpaste basically. It's ground out by a huge tunnel boring machine, and bring that back to site to use a chalk cob form of construction to rehabilitate the site. So he played around to see, you know, what can I do with this stuff that could possibly be a viable form of construction. As I said, it's a historical form of construction in the UK, so that was a starting point. And then he looked at how to keep the existing factory buildings, which were clad in asbestos materials, strip them back, keep the steel frames as a lateral support for then this new chalk cob construction. So again, this is another example of a kind of constructional model that's made at scale, keeping the factory structure to keep lateral stability, and then building. Maybe I'll just do one more. Yeah, so one more, again, a sort of contextual one. It's looking at clay in London. And so there's a period in London where, you know, a lot of contemporary London's built in clay, which happened largely over a period of a couple of centuries. And there are often clay pits, you know, local clay pits, or some of the London houses are the clay's dug out from the basement level. They fire the bricks on site and then build the house. So there's this kind of rich history which has sort of petered out now for a number of reasons. And at the same time, you know, there's a huge amount of clay coming off of London construction sites where it's just excavated because London is predominantly clay. So again, Dan looked at how you could loop this clay back into a construction cycle in London for new build housing, using, you know, modern forms of construction to give tailored results, robotic printing. And I think most interestingly, he was interested in taking the historic solid wall brick houses and looking at how you could develop a clay retrofit system that would give an insulative performance to these buildings, but where there's still some sympathy around the material culture. So this is done in the UK, but often it's done with plastic insulation and softwood, which rots after 10 years. So why not do it in clay? So that's what he played around with. And you know, these are the sorts of methodologies that students can use now, which to sort of investigate these interests. So he chose a house, a friend of his. Using a phone, you can get decent photogrammetric 3D models. He started to develop tailored parts to retrofit the house, and then he started to print a few, and then started to bring it back to the. Okay, I think I'll leave it at that. So.